Greetings and welcome. In this session, we will see a numerical to find cooling capacity, sensible heat factor and vapor removed from the air. In previous video sessions, we have discussed about the fundamental knowledge which is required to solve this numerical on air conditioning system. We have seen different types of psychrometric processes with the help of psychrometric chart, and also we have discussed about the use of psychrometric chart to find or to obtain the different properties of moist air. Now here in this video session, with the help of that knowledge, we will solve a numerical. So to solve the numerical, let us have statement. So an atmospheric air at 30 degrees Celsius dBT, dry bulb temperature and 75% RH means relative humidity, enters the cooling coil at the rate of 200 cmm means meter cube per minute. The coil dew point temperature means apparatus dew point of the coil 14 degrees Celsius, and bypass factor of cooling coil is 0.1. We have to determine 4 parameters: temperature of air leaving cooling coil, capacity of cooling coil, amount of water vapor removed per minute, and sensible heat factor. So first of all, we will enlist the data, given data. So in this numerical, the condition of air coming from the outside is given with the two properties. One is a dry bulb temperature 30 degrees Celsius and relative humidity, that is a 75%. So this we will use to locate the point 1 on the psychrometric chart. Then dew point temperature is given, that is apparatus dew point. So by using that, we will locate the ADP on psychrometric chart. So by joining this on the psychrometric chart, then this process will be cooling and dehumidification process. Let us see that process. So as per the given data here, a combination of 30 degree dBT and here 75% RH. So we get this point number 1, and apparatus dew point temperature 14 degrees Celsius. All the ADP points are lying on this line. This is called as saturation curve. So this is a apparatus dew point temperature point. If you join this 1 to ADP, then we find this process. If you see this process, this is one of the processes what we have studied in a psychrometric processes video session. As per that knowledge, the name of the process is what? Cooling process, because the temperature is a dry bulb temperature is decreasing, and here moisture content is also decreasing. So that is why it is a dehumidification. So this is a process, cooling and dehumidification, which occurs in this numerical. Now in this case here, with the concept of bypass factor of cooling coil, here this is a temperature of cooling coil, this is a inlet temperature. So outlet temperature of cooling coil will come in between 1 and ADP. So that is why this point number 2 will be coming here in between. So that temperature we don't know. So that temperature we can find with the help of formula, that is a bypass factor for the cooling coil. So bypass factor means what? Contact factor. So there is a general formula, that is what? Opposite side difference of this whole process divided by total difference, which is difference between 2 and ADP divided by difference between 1 and ADP. So that is why the formula for the bypass factor of a cooling coil can be written in this way: TD2 minus ADP divided by the whole difference of the process is TD1 minus ADP. Now we are given bypass factor in the numerical, that is 0.1. TD2 is an unknown that we have to find, and ADP is given 14. TD1 temperature is 30 degree Celsius minus ADP. So by doing the calculation here, we can get value of TD2. So that comes 15.6 degree Celsius. So this is the answer of this first required question, that is temperature of air leaving the coil. Now we will go to the psychrometric chart, and there at 15.6 in this way we can locate the point number 2, and then we can get the further parameters which are required to solve the next part of the numerical. So this is a actual psychrometric chart. On the chart, the inlet condition is a 30 degree Celsius dBT. So we find here this point 30 degree Celsius, that is a TD1. From this we have to go 75% RH line. So this is 75% RH line. This way on the psychrometric chart, here we will get the intersection point. So this point will be point number 1 on the 75% RH line, and this will be value of 5.1. Relative humidity is indicated by 5 later. Then we are given ADP of the coil, that is 14 degrees Celsius. So this is a saturation curve on this. Here is a 15. So this point will be 14 degree Celsius. So this point we can see also here 14 degree Celsius. So this point is ADP point. ADP. So this is a point number 1. This is the point ADP. Then we can join the 1 to ADP properly. Thus we will get this process, that is a cooling and dehumidification process. Then by using the bypass factor calculation, we have got the temperature of point number 2, which is lying between this 1 and ADP. So that point number 2 temperature we have obtained 15.6. From here 15.6 temperature we will take reference. So 15.6, from that if we take a vertical line properly with the help of scale while you are drawing on the psychrometric chart, then you will get here this line touching to this process line. Here you will get point number 2. So this will be the coil living point, that is a point number 2. Second small part of the question which is asked, that is what to find the capacity of cooling coil. So the process which occurs in the cooling coil, that is effective process 1 to 2. So between 1 to 2 we have to find the enthalpy difference. So for that purpose we have to get enthalpies from this point number 1 on this scale, and this is a point number 2. If you project in upward direction on the enthalpy scale, then here H1 enthalpy, this point enthalpy, this enthalpy, here you will find 82 kilojoule per kg, and this H2 enthalpy we find 43 kilojoule per kg. So we got here these two enthalpies. Now the fourth part of the question is what? To find sensible heat factor. So sensible heat factor means what? During the process 1 to 2, the heat, amount of heat that is added to this air from the outside, that heat will be total heat. That total heat is what? Summation of sensible heat and latent heat. So here we have to do one process to obtain that sensible heat factor. So for that we draw one horizontal line, and here we get point number A. So here we find this triangle now. So in this triangle, this 1 to 2, this is actually total heat, amount of heat added to the air, and this total heat has two parts, sensible heat and latent heat. So part A to 2, this part will be what? Sensible heat, and this 1 to A, this part will be what? Latent heat. So here this point number A, if we project on the enthalpy scale, so here we find the HA enthalpy like this. So this HA enthalpy we find here. HA, and it comes 58 kilojoule per kg. Now this enthalpy we will use when the calculation of sensible heat factor will come. But now at a time we found all, or we obtain all the enthalpies regarding the cooling coil process. Now to find the cooling capacity of the coil, what is the formula? That is what? Mass of air supplied, m dot A, multiplied by enthalpy difference. So formula will be what? M dot A into H1 minus H2. Now mass flow rate we have to find, but in this numerical, what is given here? Volume flow rate is given. So that is given 200 cmm. So that means meter cube per minute. So we have to convert that into meter cube per second by dividing it with 60. 3.33 meter cube per second. This this volume flow rate now we will use to find the mass flow rate. Now for that purpose we need specific volume of the air supplied. So here is a supply point 1. We have to find specific volume. So we will draw a line passing through this point number 1 parallel to the specific volume line. So these are specific volume line, this one and this one. So if you see this line, then this line is coming between 0.88 specific volume and here is 0.9 specific volume. So to find VS1 will be what? 0.88 plus, means specific volume of this line, and beyond that this point if you see, so this distance if you see, so that point 1 is approximately at 1/3 distance between these 2 points. So that is why we can find the specific volume in this way, that is a 0.88 plus 1/3 bracket difference of these two specific volume lines. So 0.9 minus 0.88, this will be what? Difference. So this specific volume comes by the calculation 0.8867 meter cube per kg. So this specific volume we will use in the calculation of mass flow rate. Now in the calculation we will use the enthalpy H1, that is 82 kilojoule per kg, and this 43 kilojoule per kg. So cooling coil capacity formula is m dot A into H1 minus H2. Further, mass flow rate is a formula volume flow rate divided by specific volume into this enthalpy difference. Now all the values, volume flow rate 200 cmm, that we have converted into meter cube per second. Specific volume we have obtained from the psychrometric chart, H1 and H2. These are the enthalpies at the end of this cooling process obtained from the psychrometric chart. We have put all the values over here. If you do the calculation, we find this answer in a kilowatt. And further, if we divide it by 3.517, then we find this answer in ton of refrigeration, that is a TR. So this is what answer number 2, cooling coil capacity, we have obtained. So cooling process is between point number 1 and 2. These are the points already we have taken from the previous slide. So to find the amount of water vapor removed between these 2 points or during this process, what we have to do, we project the line on the scale on the right side from these points. So from the point number 1, here we will find the specific humidity of point number 1, W1, and here we will find the specific humidity of point number 2. Now here is a scale provided, how to calculate or obtain. So here if you see, there are small divisions. Value of one small division is 0.0004. So here the reference is 0.020, and here this is next to this 0.020 by division 1, means we have to add this division 1 value. So in this way we get specific humidity of 0.1. This is a W1 value. Similarly, this is in kg per kg of dry air. Similarly, we can find this value. Now if you see here, the reference 0.0100 plus here this point is above by the 2 division. So 2 division means we have to take double of this 0.0004. So by doing this calculation, we find the value of this point, that is 0.0108 kg per kg of dry air. So this is a humidity of point number 2. So now these 2 values, W1 and W2, we will use for the calculation of the water vapor removed during this cooling and dehumidification process. So for that, let us go to the calculation page. So under this subheading, that is amount of water vapor removed, the formula as per the discussion, that is m dot A into humidity difference during the dehumidification process between point number 1 and 2. M dot A is ratio of volume flow rate to the specific volume. Now here, as this amount of water vapor removed, this is expected, or this is asked to calculate in a unit, kilogram per minute. So that is why minute. So that is why we will use the supply rate in a meter cube per minute, which is given to us, that is 200 cmm cubic meter per minute. That is volume flow rate of the air given, supplied. So that as it is we will take, so that we will get the final answer in kilogram per minute. So putting the value of this divided by this specific volume obtained from the psychrometric chart and specific humidities obtained at 1 and 2 we have put, and finally we got this answer number 3 in a kilogram per minute, that is for the amount of water vapor removed. So now in the fourth sub calculation part under the heading SHF means sensibility factor. Now sensibility factor is what ratio of sensible heat to total heat. This can be understood with the help of this diagram. This is a psychrometric chart already we have discussed. Process 1 to 2 cooling process. During that, this is a total heat removed. This total heat is divided into two parts. Horizontal part is a sensibility, vertical part is a latent heat. Now sensible heat is what actually difference between point A and 2. So formula will be for the sensible heat HA minus H2. At the bottom need total heat. So total heat, that is point number 1 and 2. That is why at the denominator H1 minus H2 comes. So now already we have obtained the values of point number 1, A and 2 of the enthalpies on enthalpy scale on the psychrometric chart. So these values H1, H2 and HA, these values we will put in this formula. So here HA value minus H2 value divided by H1 value minus H2 value. So by doing this calculation we find sensible heat factor. That is our final question subpart answer, that is a 4. So finally by solving the numerical we have obtained all the outputs that we will write. We were asked first, that is temperature of air leaving coil, that is a point number 2. Dry bulb temperature we have got here in the degree Celsius. Capacity of cooling coil we got in a ton of refrigeration. Third, water vapor removed during the cooling process in kilogram per minute. And finally, sensible heat factor. So in this numerical we have seen the process to find the different parameters, that is a cooling capacity, water, amount of water removed, or to find the temperature of cooling coil, one of the temperature, sensibility factor, by using the concept that is a cooling load estimation. Also we have used psychrometric chart to find the different properties of the moist air. So let us meet in the next video session of HVAC. Thank you.